First of all, some information about me. My name is Roland Kuntár, and I graduated as a meteorologist in 2015. And I have been working as a weather forecaster at the Hungarian Meteorological Service since 2016. I work in shifts. My main tasks are forecasting short and medium range, communicate alert and warnings in connection with severe weather, and explain the weather changes to the media and to social media platforms. And this is my second briefing. Now, during the first part, I will tell you some information about the current weather situation. This Airmass image shows for us the most important weather conditions over Europe at 0 UTC. An anticyclone determines the weather over the larger part of the continent. Frontal zones cross only the western and northern countries. The thick clouds of the fronts are there with white color. Over some places the weather is rainy, but the northern parts of the fronts the weather is snowy in many places. The mild tropical air mass with greenish color comes from southwest and move towards to the northern latitudes. Meanwhile, cold air mass move to south over the Black Sea, Turkey, and the Balkanic region. We found cold air mass. Polar air mass with purple bluish color over Ireland and the northern parts of Scandinavia. And from northwest with the reddish color, cold and dry air come behind the cold front near Iceland. Over this region there are cumulus clouds. And you can see it better in this picture where we show the temperature of the 850 hectopascal level. The temperature is below 0 Celsius over the northwestern and northern countries, and of course the southeast part of Europe. In the other parts of the continent, the temperatures are above 0. Over big area are around 10 Celsius. Now let's talk about the area of the anticyclone. This natural color picture was made yesterday around 12 UTC. We see very well the cloud-free, snow-covered areas with turquoise color. There are thick snow layer, for example, over the Alps, the Carpathians, or the Dinaric mountains. On the right side, you can read the snow depth measurements at 6 UTC yesterday morning. We can't see the thick snow layer over the northeast part of the continent on the natural image due to the clouds. This image has an additional problem. Use the same color to show ice clouds and snow. The area of the large anticyclone were cloud-free or mostly covered with low-level clouds and fog. Now let's look at the evolution of the low-level clouds and fog during the last 24 hours on other useful images as well. The night microphysics image is the best choice to follow the evolution of the low-level clouds at night. We see it with yellowish gray color, for example, over Po Valley in Italy, smaller patches over Czech Republic or near the border of Romania and Bulgaria. This image shows the clouds of the fronts with reddish color. The fronts moved a bit to east over Western and Northern Europe at night. Now, the increase of the cloudy, foggy area continued at dawn. Fog appeared, for example, over Austria or Hungary. We used the 24-hour cloud image at this time because the night microphysics channels are more sensitive due to the sunrise. We see the difference of the two pictures. The 24-hour cloud image gives us more visible, better separated information at dawn. For example, the cloudy, foggy area over Bulgaria. Now let's jump and take a look to the HRV fog image for the Carpathian Basin, where we see the fog and stratus covered and of course the snow-covered area with higher resolution. During the night, fog and low-level clouds formed some places in Slovakia or Austria, increased the cloudy area over Czech Republic, and over the southeast part of Hungary formed fog at night, and it started to move to north with low-level flow. And there is a fog as well near our biggest river, the Danube. At dawn, some cloud shadow over the foggy area, what you could see on the first two pictures on the bottom, but you can see the third picture, some shadow over the foggy area, what disappeared when the sunrise ended. It was a cold night. The bigger part of the area was frosty. You can see the lowest temperatures over Hungary on the right side. And last but not least, a quick forecast outlook. On the first day of February, the cold air mass start to move to Central East Europe. Cold front will arrive and will increase the chance of rain and decrease the size of foggy and sunny area. But it won't be a strong cooling. As you can see, next week the weekly temperature anomaly will above the average over the larger part of Europe. Only the thick snow-covered northern areas will be the temperature anomaly below the average, based on the current model calculations. And that is the end of the first part. Thank you for your attention. On the second part, my colleague András Vaszkó will present for you an interesting study case.
Thank you, Roland. Welcome, everybody. Good afternoon. First of all, some information about me too. My name is András Vaszkó. I graduated in July 2018 with a Master of Science degree at the Eötvös Loránd University. I've been working in the Hungarian Meteorological Service, EUMeTrain, since February 2018 as a severe weather forecaster, but I also perform tasks in general forecasting, for example, short range and middle range too, Furthermore, I'm a member of the social media team of this service. I brought a very interesting study case from the 23rd of December focusing on Hungary. Maybe that is a memorable weather situation from some colleagues before Christmas. At first, this is a natural message from the 23rd of December before 12 UTC. You can see a frontal zone with northwest-southeast axis over the center of the continent. This frontal zone had thick ice clouds marked with turquoise and also low-level clouds marked with brighter whitish clouds. By the way, in this message, not only the thick ice clouds have a turquoise color, but also the snowy icy surface, as you can see, for example, in the western part of the Alps. This is an RGB Airmass message from the same time. This frontal zone separated the cold Arctic air mass from the warm subtropical air mass. Former is marked with purple, bluish, reddish, pinkish colors, as you can see on the northeastern part of the continent. And the latter is marked with greenish, bluish, yellowish, orangish colors, as you can see in the southwestern part of the continent. So you can see the jet stream with white colors, and this is a well-defined strong jet stream on high levels, exactly on 300 hectopascal from the North Atlantic Ocean across the North Sea, Central Europe to Turkey. And this jet stream draws out for us that long, sharp frontal zone. On the next picture, we can see this sharp frontal zone at the level of 850 hectopascal too, with the geopotential distribution and the temperature of this level. This message is from the 23rd of December 15 UTC, and we can analyze an extensive low pressure system with center point over the Baltic states. This point was marked with the letter A, and this very long waving frontal zone belongs to this low pressure system. That frontal zone separated, as I mentioned, the cold Arctic air mass from the warm subtropical air mass. In this picture, the former is marked with bluish color and located the northeastern half of the continent, with the temperature of this level was in negative range, and the latter is located in the Atlantic Ocean along with the western and southern countries of Europe. Now, let's check the Carpathian Basin and Hungary. This situation in Hungary favored cloudy weather, precipitation, and temporary intense snow in the northeastern half, northeastern 2/3 of the country, as you can see in this radar image with the snowy pictograms. More snow fell in the central part of the country, But we cannot see this from measurements because most of the snow had melted until the next morning, 6 UTC. And I will explain the reasons in the following pictures, where you can see the evolution of the current temperature in Hungary. This is the first picture of this from the 23rd of December before 16 UTC. At that time, the temperature was around 0 degrees in a large area within the snowy landscapes. But at the same time, on the southwest part of the country, it was milder, as the inflow of mild air had already begun there. For example, 8 degrees were measured in the northwestern border region. In these places, the form of the precipitation was already rain, by the way. Let's see the next picture of the temperature. This picture is from the 24th of December before 7 UTC. The previous night, the temperature did not decrease, but increased in most of the country. Temperatures were measured several degrees above 0 degrees almost everywhere. This was the main reason why the snow melted. And let's see the last picture of the temperature. This is from the 24th of December, 14 UTC, when the weather was already very warm compared to the general main temperature in December, because the mild air flooded into the country. The temperature was below 5 degrees only in the northeastern border region, as you can see. But elsewhere, the temperature values between 5 and 11 degrees were typically measured. And in normal situation, you can see in this picture, in an animation, but I think in this construction, this animation isn't worked. So you could see that the usual spring has arrived for Christmassy to our country, but Christmas was always white, lots of parts in our country, as you can see, for example, in this picture. By the way, a lot of people decorated the Christmas tree at that time while it was snowing outside. These moments brought the white Christmas feeling for them. Thank you for your attention.